All right, welcome everyone. Today we're going to take a tour of the internet. But, not the internet you think you know. We're going to peel back the curtain and see how it actually works. And we'll use one surprisingly simple idea to make all this complex networking stuff finally click.
So let's kick things off with a pretty big question. What if the internet wasn't this vague, floaty cloud? What if it was actually a bustling, organized city? This is the core idea we're going to run with today, and I promise you, it's an incredibly powerful way to make all of this networking stuff finally make sense. You'll see. Okay, first stop on our tour, the city's foundation, which is all about roads and addresses. Because, just like any real city, the internet needs a solid grid of roads and a super clear way to find things. In our digital world, that means networks and IP addresses.
So what is an IP address exactly? Well, the easiest way to think about it is like a unique street address for every single device connected to our digital city. Yep, everyone. It's just a series of numbers that tells the Digital Postal Service, hey, deliver this data right here to this specific spot. Now, these addresses in our city, they actually come in two different flavors. On one hand, you've got a static IP. This is like owning a house. You have a permanent address that never, ever changes. It's perfect for something like a public website that always needs to be found at the same location. Then, on the other hand, you have a dynamic IP. This is more like staying in a hotel. You get a temporary room number just for your stay, and that's usually what your laptop or phone gets when you connect to Wi-Fi. I mean, let's be real. Nobody wants to memorize a bunch of long, random numbers, right? Of course not. And that's exactly where the domain name system, or DNS, comes in to save the day. Just think of it as the city's official directory. When you type in something easy like google.com, the DNS does the hard work. It looks up the real street address for you and tells the network exactly where to go. It is, quite literally, the internet's phone book. All right, so we've got our roads and addresses all mapped out. Now it's time to check out the city's public services. All the automated systems that work behind the scenes to keep everything running smoothly. First up on our public services tour is something called DHCP. I like to think of it as the city's friendly welcome wagon. So whenever a new device joins the network, like when your phone connects to the coffee shop's Wi-Fi, DHCP just swoops in and automatically gives it a temporary address and all the other info it needs to get online. The best part? It all happens automatically. You don't have to do a thing. Okay, get ready for a real aha moment here because this next one is a game changer. It's called NAT, which stands for Network Address Translation. Just imagine a giant skyscraper with hundreds of different offices inside, but it only has one public mailing address on the front of the building. NAT is like the mailroom in the lobby. It takes all the incoming and outgoing mail and makes sure it gets to the right person in the right office. This little trick is literally the reason the whole internet didn't run out of addresses years ago. It's how your entire house, your laptop, your phone, your TV, all of it can share just one single internet connection from your provider. You ever wonder how a massive website like Amazon or YouTube can handle millions of people all at once without just crashing? Well, the secret is something called a load balancer. Think of it as the city's master traffic cop. It stands at a busy intersection and intelligently directs all the incoming traffic across a bunch of different servers. This prevents any one server from getting totally overwhelmed, which keeps things fast and reliable for all of us. So, how do you quickly check if someone's even home in our digital city? Easy. You use a tool called ping. It's kind of like sending a town crier to a specific address to just shout, "Hey, are you there?" If you get a shout back, you know that device is online and listening. It's the absolute go-to tool for any kind of basic connectivity troubleshooting. Okay, so we've figured out how to get mail to the right building in the city. But what about getting it to the right department once it's inside? Let's dig into that. Well, this is where port numbers come into play. See, while the IP address gets the data to the right computer, the right building, the port number gets it to the right application on that computer. It's basically the apartment or suite number. So your web browser's listening on one port, your email app is on another, your game is on yet another. It's how the mail finds the right resident inside the building. Okay, here's a quick one, but it's super important, especially for any developers out there. It's called Localhost. The address, and you'll see this everywhere, is 127.0.0.1. The best analogy? It's like talking to yourself in a mirror. It's a special address that lets you test applications right on your own machine, so you can run both the client and the server locally without your traffic ever having to leave your computer. All right, so we've mapped out the city, we know how to deliver the mail to the right address and even the right apartment. So what's next? Well, now we need to learn the official language of the web, HTTP. Communicating with HTTP is a lot like going to a library. Think about it. You don't just wander into the stacks and grab whatever you want. No, there's a process. First, you fill out a request slip. That's your HTTP request. Then you hand that slip to the librarian, who is our server. And then the librarian goes and gets the book for you. That's the HTTP response. It's this simple back and forth request and response cycle. Now, the most important part of this whole thing is what you actually write on that request slip. These are called HTTP methods, and you can think of them as the action verbs. The big ones are get, post, put, and delete. So a GET request is just you saying, hey, get me this book. That's what your browser does every single time you load a web page. A post is more like, please add this new book to the library's collection, which is what happens when you say submit a contact form. A put is for updating something that's already there, like update the information for this book. Think editing your social media profile. And finally, delete is exactly what it sounds like. Remove this book from the library. Simple as. So let's look at what a real request slip actually looks like. Here we have a sample GET request. That very first line tells us everything we need to know. The method is GET. We're asking for a specific resource, in this case, a book with a specific number, and we're speaking version 1.1 of HTTP. Then that host line just tells the digital mail carrier which library or, which website this request needs to go to. And here's the reply from the librarian. See that magic number right there? 200 OK? That is the universal code for success. I found exactly what you were looking for. Everything that follows is the actual data, the book information you asked for, all packaged up and ready for your browser to show you. But of course, things don't always go perfectly, right? So what happens when something goes wrong? Well, in this example, it looks like someone tried to post to create a new book, but that book already existed. So the librarian sends back a 400 bad request. It's basically a polite way of saying, sorry, I can't do that. And that little message that comes with it explains exactly why. For developers, getting this kind of precise feedback is absolutely critical when they're building things. And believe it or not, that brings us to the end of our tour. We covered a ton of ground, so to make sure it all sticks, let's do a super quick recap with a little glossary of all the key terms we talked about. Okay, let's do this one more time, rapid fire. Remember, the IP address, that's your street address. The DNS, that's the city directory. NAT is that genius corporate mailroom that saves the day. DHCP is the friendly welcome wagon. A port number is the specific apartment number. And HTTP is the language everyone speaks at the library. When you see it all laid out like that, it really connects all the dots, doesn't it? Wow, we have covered so much today, from the very foundations of our digital city all the way to the language spoken in its libraries. So I'm just going to leave you with this one final thought. Now that you know how to read the map of the internet and you know how to speak its language, what are you going to build in the digital city?